Hello Year 10. Today you had some revision about the whole topic P4 atomic structure, which ties in closely with C1 from chemistry called atomic structure and the periodic table. Here are the answers to the revision and some explanations for the parts that you said were difficult today. So this slide asked you to watch a video called Atomic Number and Mass Number. Information's also on page 196 in the revision guide. So the video asks three questions. How can we use the mass number and atomic number to work out the protons, neutrons and electrons in an element? It also asked what is an isotope and what is an ion? So we'll do each of those questions one at a time. Atoms contain a central nucleus which contains positive protons and neutral neutrons. Orbiting the outside of the nucleus in energy shells are negative electrons. Atoms have no overall charge because the number of protons and electrons in an atom are equal, so their charges cancel each other out. We can find these numbers on the periodic table. The small number is the atomic number and tells us the number of protons. The large number is the mass number and tells us the number of particles in a nucleus, so the number of protons and neutrons. You can work out the number of neutrons by subtracting the atomic number from the mass number. Isotopes are atoms of elements with different numbers of neutrons. Atoms of an element always have the same number of protons. The protons determine the element. Ions are atoms that have an overall charge because they have gained or lost electrons. Positive ions have lost an electron, and negative ions have gained electrons. This is a copy of the periodic table that you are given in exams. I realised when I was marking this that Mr. Ahmed had set some questions that were impossible to solve with this version of the periodic table, and I want to reassure you that that won't happen in any exams. So to work out which element has 92 protons, you need to look along the small numbers until you reach 92, which was not possible on either of the periodic tables you had access to. So well done to Google for finding out that this element was uranium. The element with the mass number of 222, you go along the big numbers, the mass numbers, until you reach 222, and this was radon. The element in group 2, which is the second column along from the left, and period 7, which is the 7th row down, remembering that hydrogen and helium are in period 1, you should see radium. The element with 126 neutrons, so you're looking for 126 when you have taken the small number away from the big number. And many of you correctly identified bismuth. I hope that you didn't just ask Google. Atoms have a radius of 0.1 nanometers, and the radius of the nucleus is 1/10,000th of the whole atom, which is 1 times 10 to the minus 14 meters, so very small. Most of the mass of an atom is contained in the nucleus. The keywords that we need from this section are the following: mass number, the larger number which tells you the number of protons and neutrons in the nucleus. Atomic or proton number, the smaller number that tells you the number of protons in an atom of that element. The electron number is equal to the number of protons in the atom. And isotopes are a version of an atom with the same number of protons and a different number of electrons. These two videos told you about the alpha scattering experiment, which was a key turning point between the early ideas of the structure of the atom, which we called the plum pudding model, and the modern model of the atom, which is referred to now as the planetary model. The ancient Greeks said that everything was made of atoms, and they believed that atoms were tiny spheres that couldn't be divided. In 1897, scientists discovered that atoms contained tiny negative particles, and they called these electrons. This showed that the atom was not a sphere, and that could not be divided, but it actually had an internal structure. Scientists now offered a different model of the atom that they called the plum pudding model, which suggested an atom was a ball of positive charge with electrons embedded in it. Scientists wanted to know if this model was correct, so they did the alpha scattering experiment, and they took a piece of gold foil. They chose gold because it could be hammered until it was just a few atoms thick, and alpha particles were fired at the gold foil. Most alpha particles passed straight through. Some were bent off their path or deflected, and some bounced right back at them. And the results told scientists three things. Firstly, most of the atom was empty space, which is why they went straight through. Some of the alpha particles were deflected, which told the scientists that the center must have a positive charge that was repelling the positive alpha particles. And the ones that bounced straight back showed that the center was dense and contained a great deal of mass. We now call this center the nucleus. The plum pudding model was replaced with the nuclear model, with a central positive nucleus, and the electrons were outside and around the nucleus. The nuclear model was again adjusted following the discovery of energy levels or electron shells and the discovery of protons and neutrons. So this question asks you to summarize the two models. The plum pudding model, which had electrons that was spread out in the atom. The atom was a ball of positive charge and it was full, solid. The nuclear model also had electrons. The positive charge was concentrated in the middle, but the electrons were orbiting the nucleus and most of the atom was thought to be empty. Okay, this next video summarized alpha, beta, and gamma radiation. We had a live lesson about these three types of radiation, and you can also read about these on page 196 in your revision guide. This next question I feel is quite badly asked. I believe that there were two mistakes, and that without these mistakes being corrected, the only type of radiation you could know for certain was gamma radiation in the middle row, which is most penetrating. So for this reason, I accepted a mark for any answer that had gamma correct. Okay. To summarize the information we know about each type of radiation, you can see that an alpha particle, let me just get my highlighter here, an alpha particle has a mass number of 4 and therefore a mass of 4. There are 2 protons shown here by the atomic number, this lower number, which means 4 minus 2 says there's 2 neutrons. So the radiation is made of 2 protons and 2 neutrons. It has a positive charge because it has those protons there. Beta is a high-speed electron and represented here with this information. The mass number of 0 means it has 0 mass. Beta is a high-speed electron, and electrons are negative, so it has a charge of -1. Gamma rays are waves of electromagnetic radiation released by the nucleus. They have no charge and no mass, and have no effect on the nucleus of the atom. So, this video was about half-life. The half-life is the time taken. So if you ever have a half-life question, your answer is about time. The time taken for the number of radioactive nuclei in an isotope to halve. So we had a question here. The half-life of this substance is the time taken for the count to halve. It starts at 80 on the y-axis. So how long does it take to get to 40? And then how long does it take to get to 20, which is half of 40? And you can see from the lines that I've drawn down that each of those answers was 2 hours. So what's the half-life of this substance? 2 hours. If the element starts with a count of 96, what would it be after 8 days? So you can start by dividing 8 by 2. If we know the half-life is 2 days, 8 days divided by 2 means it's 4 half-lives. So half 96 4 times. You can see I got 48, 24, 12, then 6. Radioactivity never reaches 0 because the number always halves. Okay, nuclear decay equations are on page 197 in your revision guide. Again, we had a live lesson about these equations. Also, I didn't get very many emails, or any emails in fact at all, asking for help on this topic. So make sure that you look at this on page 197 in your revision guide. Alpha particles will reduce the mass number by 4 and the proton number by 2. So if we have a look, there's an alpha particle. It's going to reduce that number by 4 and that number by 2. So if you do the maths first and you work out the numbers, what you can do after you've got the numbers is go along the periodic table and look for the proton number that matches the new number you've got. So the proton number with 101 was Mendelevium, named after Mendeleev. Okay, and this will tell you the element. So really, when you're searching for that proton number. That's the thing that's going to change. Okay. When you do beta decay will increase the proton number by 1. So you see that number there. It's just going to produce a new element that's one place higher in the periodic table. So again, you're looking along your periodic table for an element that is 1 higher. Okay, I'm not too sure about my top one there, because the periodic table I looked at has got the same symbol as that one there. So maybe that would need double checking. Okay, but that's basically how you do it. Alpha decay will create a new element 2 spaces down on the periodic table. Beta decay will create a new element 1 place higher on the periodic table. Work out the numbers first, then look on the periodic table for the proton number. Okay, I've set some extra revision on Seneca since I set this lesson where you wrote me a list of things you were struggling with. Hopefully that will address any issues just looking at it from a new point of view. Please do get in touch though if you still need help with this work. Thank you for rating your confidence. It really helps me so I know what we may need to cover in our extra revision sessions when we get back together, or whether I may need to put on extra live lessons to cover stuff that we don't have. Thank you for submitting your work as well, because that does make it faster for me to get my feedback to you. Keep working hard, keep being amazing, and I'll see you in the next video or the next live.